T.S. Muhammad Fani bin Sulaiman. The floor is yours.
Thank you, Mr. Chairman. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Distinguished guests, speakers, participants, and fellow friends. First of all, I would like to thank ASEAN Center for Energy for inviting me to be a keynote speaker for this session. I'm honored to share insight on the energy efficiency technologies and measures. The cleanest energy, as we often say, is the energy we never use, right? So today, I will highlight technologies, management, practice, and success story that show how efficiency can power up the ASEAN sustainable future. So let's begin with the global demand keep rising, yet the pace of efficiency must double to keep us on track for the net zero. The IEA scenario steps, APS and NZE illustrate how current policies fall short and why deeper efficiency measures are critical this decade. So for the ASEAN, latest trend scenarios show modest progress, while APS, LCO parts require stronger commitment. Improved energy intensity means more economic output per unit of energy, a clear sign of smarter growth. For your information, ATS stands for ASEAN Target Scenario. So we have the baseline, ASEAN Target Scenario, which means the current policy, etc. And APS stands for the APIEC, that's the current policy action of energy corporation, target scenario. And the last one, LCO, is the radical change of the energy transition for the less cost optimization. Sorry. Electricity, look at the electricity generation. Electricity demand in Asia will triple by 2050. Coal still dominates, but renewables and gas are gaining ground. We can see the trend. Balancing affordability and sustainability depend heavily on managing demand through energy efficiency. So that's why in Malaysia, this is our Malaysia generation mix. Malaysia system remain fossil heavily currently, yet solar capacity is growing rapidly and often called the first fuel. So under the NETR stands for National Energy Transition Roadmap from Malaysia. So energy efficiency form one of 6 transition pillars to moderate consumption and cut the peak demand. And we can see the projection of the ASEAN CO2 emission projection by 2050 is increased. But the first fuel for the energy transition, for the triangle, for the pyramid of the energy, we can see the most important part to do right now is that the energy conservation and energy efficiency. And balance of that will go to the renewable energy. Look at this type of energy consumer. What's the major equipment used in industry and commercial building, because it's a major user. So we have from the recent research from the academician, so the process heating, motor, boiler. So motor represent, the HVAC using the motor, right? So motor for about 30%. But the most significant energy user for the industry is the process heating, including the boiler, furnace, kiln, etc. So let's move forward to the energy efficiency technology and measures. For the heating process first. The technology, in many industry plants, a significant portion of heat from the furnace or kiln is lost through exhaust gases, leading to wasted fuel and unnecessary greenhouse gas emission. Heat recovery bank and exchanger capture exhaust energy from furnace to preheat air or feedstock, and the saving is up to 10 to 50% of fuel use when we use this technology. So for this WHR, or waste heat recovery, transform waste into available resources, reducing both cost and emission. When we're talking about the motor, most factories still operate with outdated motors of IE1 or IE2 motors, resulting in excessive electrical losses, high maintenance costs, and lower productivity compared to modern high-efficiency motor system. And in order to improve the efficiency, that's the suggestion for those industry to transform their old motors, IE1, for example, to IE4 or IE5, based on the output and the efficiency graph over here. Although initial costs are higher, definitely, life cycle savings and reliability gain make high efficiency motor a sound investment. This is my real experience with the industry. The boiler, look at the graph. The problem with the conventional boilers often run with the poor air-fuel ratios, causing incomplete combustion, heat losses, and excessive fuel consumption that reduce overall system efficiency. So what we have doing for, we did setting the blue graph over here is the manual setting for the air-fuel ratio, but when we use the technology, application of the technology for the control, for example, so the green line over there is the result. Now, what's the result for the boiler efficiency? Oxygen enriched or precise air-fuel ratio control enhance flame stability and lower fuel use by 15% approximately. So continuous monitoring ensures optimal combustion and longer equipment lifespan. Now we move forward to another system. I think this is one of the important system for the manufacturing of factory. Compressed air systems are frequently pressurized, and poor maintenance, wasting up to 1/3 of their energy through leaks and inefficient operation pressure setting. So compressor often run above necessary pressure because of the lack of the poor maintenance, operation, etc. And we can see that this from the expert and from the papers as well. 1 bar in pressure reduction produce up to 7% energy saving. Regularly leak detection, load management, and right sizing deliver quick paybacks. So this is the performance comparison for the old type and new technology of the compressed air system. Modern variable speed compressors adjust output to demand, cutting consumption by up to 25% saving, compared with the fixed speed unit and excellent retrofit for industrial facilities. Yeah, technology is good for the energy efficiency to move forward in order to cut down the energy emission. But without the sustainable energy management system is something like we can see the up and down graph. So what we want to propose for those industry or policymakers is that to have this sustainable energy management system. Sustainability requires system thinking, measurement tools, control system, and data analytics support continuous improvement of the sustainable energy management system, ensuring saving persists beyond initial project. And what's the Japanese experience is the wow results, the largest investment, medium investment, and small investment. All of those type of the investment operation measures must be under the sustainable energy management system action. This is the spirit, aim, leisure, motivation, the national energy transition roadmaps. One of the levers is the energy efficiency to optimize the energy efficiency actions, and our target for the industry and commercial energy efficiency saving up to 23%, as well as for the residential 20%. The success story of the energy management implementation for the large building, this is my, our real experience in UTM, University Technical Malaysia Melaka. Energy management for building and industry category, large building winner in 2021 and 2024, twice. We got this winner for the large building energy management. So this is our experience for the phase 1 development, phase 2, and we embed the energy management gold standard by the ASEAN. The phase 2 for the integration is the integration with what? With the current policy, current operation, and the phase 3 for the sustainability, smart and dynamic. So the saving for the full star EMGS was the 23.53%. And today, this is the sustainable achievement. After 10 years of the sustainable energy management implementation, the energy saving for approximately 490 gigajoule equal to the cost saving for about 3.5 million USD, equal to the CO2 reductions of 24,129.6 tons CO2 equivalent. So what's the key initiative? Foundation, definitely the top management commitment, energy policy, resources, development and competent person. We have many certified energy manager, registered energy manager, etc. So that's the pillars for the human development. Another key initiative dedicated center to manage the energy. Our metric as the tool to sustain the awareness level and culture. So these are the tools that we use to control the awareness level, etc. Training and motivation, staff recognition, and for the energy saving measures, we did to implement the green procurement. The green procurement for the fast-rated procurement, 5-star rating, eco-appliance, and the big one is the biggest investment that we have done before, retrofitting the inverter type chillers. In UTAM, we have 24 chillers, and all of them now has been running by the inverter type. 20,000 units of LED retrofit. The issue is VSD, and we also use the motion sensor as a strategic location, especially for the 24 hours operation. The initiative for the desktop to laptop initiative, this will cut down the energy consumption as well. Baseload scheduling, strengthening, and timer, street lighting, and we're using the timer for that. BMS upgrading, optimal chiller scheduling. So this is important to have the technology involvement to control the chillers, because chillers is one of the big energy user for the university. And we also use the IoT energy monitoring system with profile forecasting reflecting pricing signal. So the internal innovation system that have been implemented in our university. From those energy saving measures, so this is the energy saving percentage that the results speak clearly. A combined initiative developed over I think almost 30% total saving right now. Each small measures adds up to the major organizational transformation. As the conclusion, energy efficiency thrives on understanding, teamwork, engagement, and commitment. Challenge with persist, but with perseverance, sustainability become a shared reality. Thank you for your attention. Let us continue working together, academia, industry, and policymakers to make energy efficiency the driving force of ASEAN's sustainable prosperity. Thank you.
Thank you very much, Professor Muhammad Fani. So it is very insightful presentation, and it's also a coincidence because some of us, the participants of AICEE, yesterday we visited UTAM, and we had a chance to look around and to have the presentation about this kind of technology. And today we have the privilege to learn more about the energy efficiency and the technology measures from the technical perspectives from Professor Muhammad Fani. And now I would like to give the audience a chance to give a question, maybe just one question, because we have to speed up the time. If there are any questions. Okay. Please introduce your name and your institution, maybe.
Okay, my name is Elwin. I'm actually from UNSDSN, a fellow researcher. Professor Fani, I would like to ask, right, what is the return on investment in general? Because you actually implemented many ESM, energy saving measures. Which one has the longest, and why is it being implemented if it is that long? Thank you.
Thank you. That's a good question. So maybe we can back to the slide presentation, or if not, we have major energy saving measures. For example, a retrofit chiller. Okay, and then we have the policy for the investment as well. So we put target for the ROI, for example, to be less than 10 years. Not, for the some organization, they set less than 5 years. But for us, to be fair, between the, the supplier and us, we set less than 10 years. For example, for a chiller retrofit program, so the ROI is about 7 to 8 years only. So that one is the inverter types. For us, we also, we was considered to install magnetic chiller, but the ROI is longer than that. That's why we choose to install the inverter type of the chiller. So in line with our policy of investment, it's less than 10 years. For LED retrofit program, that one is the short-term payback period, less than 3 years only. So we put target to install or retrofit all of our lighting in UTAM. We have for almost 50,000 lighting. So until now, we have installed or retrofitted of the lighting for about 20,000 units. So that's my answer.
Okay, thank you very much. So because of the time constraints, we need to move forward to the next session. However, before Prof. Fani goes back to your seat, from ACE, we have a gift from you. Yes. Thank you very much. Okay. So now we move forward to the next session. We will have a photo group, a group photo. It's located in the photo booth at the front of this area. So let's go ahead. All right, thank you very much, and welcome back to the next session. So, yeah, let's move forward to the next session, which is the presentation session on the fifth ASEAN International Conference on Energy Environments, or AICEE, as part of the AEBF 2025. Please be aware that the presentation takes only 15 minutes in total. It's up to you whether you want to use it up to 15 minutes, or whether you want to complete it in 10 minutes and 5 minutes for the Q&A, but overall it's 15 minutes. And I will remind you if the time is up. So maybe if your presentation is almost up, like 2 minutes before 15 minutes, I will remind you. So don't worry about it. So sorry, I messed up my speech. All right, so let's move on to the first session. Is the investigation on factors influencing energy efficiency in ASEAN, who will be presented by Mr. and Sofiato. So Mr. and Sofiato, the floor is yours. You have 15 minutes from now.
Yes. So the first of all, I would like to pay my respects to all the researchers. I am maybe the youngest one. I just recently completed my bachelor degree, and today I am presenting on behalf of my supervisor. So today's my topic is about the investigation on the factor influencing of the energy in the ASEAN. So the introduction is first about this research is focused on the factor energy efficiency in ASEAN. Like as you know that in ASEAN we are growing faster, and also like the economic growth and the people will be grow too. So in this point that we know that the energy is like the energy demand is going high. So with the energy and the people population grow, so the more energy is in it, like in for home, for the business, or for the industry. And also with the urbanization, with the climate change, the energy consumption pattern, it can create the trend lead to the higher electricity and fulfilled use. For the energy efficiencies is the key to balance growth and sustainability. And also the collaboration the technology can optimize energy efficiency as well. So the research objects is for our research objects have the three main focus. For the first one is to identify the factor influencing the energy efficiency that included the technology call, innovation, regulatory frameworks, and also economic incentive and social behavior. With the quantize the impacts of this factor using the AI/ML approach, the machine learning model is applied to measure the influence of each factor, reveals the hidden pattern, and provides the actionable insights. With the explores out the disparities and the potential investor by comparing the country, and the research highlight the different and proposed energy tailored to the nation. So based on this research, I have like review. It's just not only of the review, but more than this, just the main point is from the ASEAN Development Bank Institutes, from the AICEE, the ASEAN Climate Change, the Energy Project, and also from the AIDIC, the ResearchGate, and the MDPI for our literature review. For the data collection, we are using the data that published by the ASEAN Energy, is the ASEAN Energy Statistics Leaflet 2023, with the ASEAN Outlook Energy and Saving Potential in East Asia 2023, the ASEAN Outlook on Energy, ASEAN Energy 2023, and also the data that we use for ML by combining the open data from KGOL and also with the World Bank and the International Renewable Energy Agency, IRENA, to collect all the part of the data for build the ML to identify the key factor of energy efficiency. So for the data processing, we are processing with the data to handle the missing or inconsistent value, like any gap, the duplicate or error on the data set that we've identified with the corrected. And also we are make the normalization or the numerals variables such as the energy consumption, electricity capacity, and emission were standard to combine the scale and unit it. And with the encoding category call variable with the non-numerical variables such as the policy type, theory framework and incentive program was converted to the format that AI and ML can process the efficiency. And also we are aligning the reporting standards across the country, like the different in the definition, the measure unit, and also the report format was in recognized. Okay, for the our analytic framework for this study is to combine the machine learning methods to ties insight to energy efficiency across the ASEAN nation. That each models method can contribute the unique to understand the pattern and driver the potential intervention, like the random forest or AICEE both this model that can use to determine the feature important, like helping to identify the key factor and that influence energy efficiency, that they can reverse with the technological policy, energy or economic social variable have the strongest impact. With the K-mean and DBA scan, we can like groups based on the energy efficiency profile, and also allow us to detect the pattern with the similar types and different across the region. With the neural network, the neural network that can predict the model and apply to the forest forecast energy efficiency outcome under the different policy or the technical scenario. With the survey classification, we are using from the public survey from the Jakarta, Indonesia, that the public survey are with the data of behavior data are applied to understand the awareness and adoption of the pattern of the energy saving practice. So the key factor that influencing the energy efficiency, that based on our research that we found with the technology. So if we are using the smart and connected grid energy efficiency as applied and renewable energy integration with the machine learning application can predict maintenance of the equipment of the optimization energy and distribution the networks. With the regulation, the energy performance standard mandatory of the energy efficiency requirement and also the carbon taxation policy. With the machine learning application, the scenario can simulate to the prevent the result from regulatory intervention. With the incentive is the subsidiaries like the tax break or also the financial mechanism for the energy efficiency investment. The machine learning application can return on investment, like predict the model to assess the efficiency of the different incentive schemes. With the social behavior, like the public awareness, cultural attitude, and also adoption of the energy efficiency practice, the machine learning application can classify and clustering to estimate the likelihood of the adoption and the energy effectiveness of the awareness campaign. With the region this year, in this research, it highlight like the country like Singapore or also the Malaysia is the leader region with the strong policy enforcement, the advanced technology adoption, and also the highest public awareness on energy saving practice. So this country benefit from the well-assembled regulation, smart grid, supportive economic incentive that result in the higher overall efficiency. But in Cambodia and Laos are face the challenge such as the limited technology adoption and also the low public awareness with the fewer incentive program to promote the energy efficiency. So these gaps contribute to the lower performance and slower progress in reducing energy consumption and emission. With the AI and ML insights, the clustering analyzes the group's country with a similar efficiency profile, share the challenge and the identification of the pattern across region. These insights support the target policy design, the tailored intervention and regional cooperation incentive, and also ensuring the strategical effectiveness and context specific. With the role of awareness is about the education. So the public awareness is a driver that for the people who understand the environmental and also the economic can benefit to the energy efficiency, because why they are spend money to buy like to get the energy, but they are using it, it's not full of use. Maybe like they are open the air conditioner and with the fan, so maybe the energy may be more used, but it's very hard to control about it. And also the community institutional campaign, the education is undertaken in school or workplace, and the local community helps demonstrate the measurable result by building the long-term awareness for early childhood to the adulthood. And also with the machine learning and behavior prediction by analyze the demographic like socio-economic factor and survey response. The ML model can identify the groups most susceptible to efficiency, best practice, and those are requiring the stronger invention. And the last is about the coupling technology, policy, and also the education to efficiency chain maximize when the technical solution are supported by the clear policy and education outreach that ensuring the adoption in both informed and sustainable. For this key finding highlight that the no single factor can try the energy alone. So it needs all technology, policy, social behavior, and also the public awareness and education. That instead a combined technology, supportive regulation, the incentive, and also the social awareness create the most powerful and lasting result. So the holistic integration, like the success come with innovation technology, are paired with the regulatory frameworks, financial support, and also the community engagement that leading into a reinforcing cycle of efficiency. The data-driven precision with the help of the machine learning and advanced analytics. Like currently we are living in AI era, so don't force it. Just use it to increase, to find some key factor that can support us in energy, because the energy is the key one that very important for environment and sustainability. So the researcher can accurately measure the influencing of the each factor, conduct the forecasting under different scenarios, allowing the advance based on decision, and also address the disparity, like some of country and region in Southeast Asia are far ahead in energy efficiency, while the other country is like behind. So I think like if Singapore or also in Malaysia can share, also host like this conference to share the idea to all the students or to all the energy youth from across the ASEAN, just to come together and can learn more and share our idea together. It's a very benefit for the energy efficiency. And also the implication. The implication energy efficiency is more than technical solution. It's about cornerstone of the sustainable development that support economy stability, the environment protection, and also the social well-being. The research point to research several critical implications for policymaker, for business and community. We need to set up a strategic important, the collaborative action, and also the machine learning for governance. In the conclusion for the examined research, that finding the several key images that summarize how ASEAN can improve the energy efficiency. These points highlight the importance of the inspiring multiple factors, leverage data-driven tools, addressing regional disparities, and fostering collaboration to achieve a sustainable energy. The key factor is about like the holistic approach is key. Integrate technology, regulation, economy, incentive, social behavior are try the strongest energy efficiency outcome in ASEAN, like the economic expansion, the urban life, and the climate change make the efficiency critical for cost saving, emission reduction, and energy security. With the data-driven method can help identify the key driver, quantify the impact, forecast the scenario, and also highlight the regional disparities. And also like we identify that in Singapore and Malaysia showcase the successful model, while the Cambodia and Laos need the tailored invention and also the knowledge sharing to improve the efficiency. With the collaboration or awareness with the government, industry, and also the community, most collaborate with education and analytics to achieve the sustainable energy. And also the vision for ASEAN, those combine the strength goal guides the region toward a more sustainable and resilient and efficiency the energy for the future. Okay, thank you so much.
Thank you very much for the presentation. You still have 2 minutes for the Q&A session, just in case anyone has a question for Mr. Ansofiatoch. If there is no questions, so let's conclude this presentation.
Yes.
And then thank you very much. Let's give a round of applause for Mr. Ansofiatoch. Thank you. So the next presentation will be delivered by Mr. Alwin Tong, Alwin Long, Alwin Long, I'm sorry. So the title of the presentation is Zero Energy and Low Carbon, ZAALC, Building as a Low Carbon Neutrality Solution for Micro, Small, Medium Enterprises, MSMEs. So the stage is yours, Mr.
Okay, very good morning. Thank you, Mr. Chairman. Okay, this is my presentation. It is about zero energy and low carbon building as a carbon neutrality for SMEs. Okay, the conceptual framework is the approach to build upon materiality assessment on SDGs and to apply on the hexahelix model, engaging with government, industry, academic, NGOs, communities, and also funders. Of course, the goal is to achieve the SDGs and to meet the SME's ESG, all right? Okay, as a company, these are what we do. We actually have these 4 pillars that we applied in: energy audit, sustainable energy management program, ESG, and also inclusive rural electrification. So back in 2022, what we did is we actually did the materiality assessment by engaging 6 different actors. From there, we have established the fundamental, intermediate, and also advanced methodology to achieve carbon neutrality for a small little company. Okay, and today's presentation is to focus upon zero carbon energy and also EE or electric mobility. Okay, the carbon neutrality roadmap follows 3-phase carbon neutrality. Phase 1 is to establish the GHG and to build the thing that is required. The second phase is to build the zero energy building and to embark on electric vehicle in order for us to achieve that. And phase 3 is to get it verified, all right? So this is the carbon neutrality roadmap for the organization. What we did, we actually had it completed this part, and currently we are at this stage, all right? The initial exercise was to reduce about 30%. When we reach this level of reducing it to 100% for scope 1 and scope 2, that is for your direct combustion and also your indirect combustion, that's when we will be able to achieve 100%. While the inclusive rural electrification is the one that's going to bring us towards carbon neutrality for scope 1, scope 2, and scope 3, all right? So the design strategy for this zero energy building is through passive design, active design, renewable energy system, carbon sequestration, and validation and verification. All right, so let me just walk through. This is a site plan. This is an actual site, okay? So it is not academic, so I hope it is a combination of both. I am an academician, but at the same time, I'm a sustainable practitioner. I think that is why it is a little bit more. So this is the site. As you can see, it is a huge green coverage, but that is not the carbon sequestration that we have because we have no control on the entire land. What we have is only the small part, okay, which are the one that's being plotted out. Okay, we have origin of more than 30 centimeter diameter trees that we measure them. We make sure that we do not bring them down so that we can have this as our carbon sequestration. To top it up, we also have a bush, about 10 to 30 centimeter trees that we measure, and we make sure that we don't chop it down. We have a pond that is overflow of rainwater harvesting. As you know, Malaysia is in the equator. We have rain all year round. So we have excess of water most of the time. And that water will be used for irrigation. So we have fruit trees so that we won't go hungry. If we can get about 30% of self-sustaining by planting vegetables and so on, then it will be sustainable. Is it going to be for a large scale? No, it is actually for a small scale, all right? Okay, hear me out. We have this tool, which is called Pathfinder. You can Google and find this. You can count exactly that area of carbon sequestration, and it is validated. So we are able to have a sink of 2.35 tons of CO2 per annum just by the small plot. If I were to have the entire land, I think I will have probably 10 times the figure. But to be fair, we only have control on that area. That is, therefore, we only articulate is about 2.3 tons of CO2 per annum. Okay, so this is the design concept. The one on the right at the bottom, that is how the open area is to be left as it is, and also to plant for self-consumption as well as carbon sequestration. Right, the passive design. Okay, the orientation of the building is southeast. So we are able to have the wind coming in order to flow through on cross ventilation as well as stack ventilation. So it is a bit on the architectural design. On the active design, we only use 5-star rating equipment. Okay, we have passive design by using louvers so that we have good ventilation while bringing in sufficient lighting and not too much. Okay, so we have submitted this particular building for green certification for validation under MyCrest. The active design, if you can see on the left-hand side, we have broken down them into HVAC, heating, ventilation, and conditioning, lighting, kitchen appliances, plug load, laundry, and EV charger. See, I have the baseline design with no star, all right, and the EE design with 5-star. So you can see how the kilowatt hour per day of consumption would be like before and after. So if I were to just go into the highlight, okay, we are emitting Scope 1 and Scope 2 0.01 tons of CO2 per annum. Okay, that is conceptually. I hope to have that validated in due time. Currently, the construction is still ongoing. Okay, the technology would be applying passive design with louvers and also using prefab about 30 to 70% of the materials. Okay, and the renewable energy, we'll be applying solar PV to get a building energy storage system. That is how we are able to achieve zero carbon for Scope 1 and Scope 2. All right. For the benefit of the audience, the Scope 1 is where we are generating power through solar power, therefore it's zero. And then we are driving around to meet customers to offer up our services. So the way to be able to reduce that is actually either to walk, right, or we can actually use an EV that is powered by the solar, which is above our roof. All right? And the other technology that we are looking forward to apply is the biogas digester. On average, there's about 5 to 10 kilogram of waste, food waste, per household in Malaysia. So we can convert that into biogas, therefore we will reduce our consumption of LPG. Okay, so we have an estimation about 5.8 tons of CO2 per annum carbon emission avoidance. Okay, so this is actually the construction. We started off groundbreaking in June. In July, that's where we did our piling. The piling had to do a few times because of the soil condition, but in August, that's when it started construction. As of now, it is in October. We have it more or less about 40% of its, this is the drone footage, 40% of its construction, okay, with the intention of achieving carbon neutrality as for small, medium, and enterprise in Malaysia. That's the end for my presentation. Is there any question?
Still have 7 minutes for the Q&A session. Sure. Okay. Good.
Dr. Long, let us ask whether the biogas production is actually meant eventually for consumer-grade usage.
Yeah, that's a good question. See, most of the biogas are very corrosive. Right. That is why we are working with another research company to have a scrubber. But in a more layman term, right, we will be using things which are readily available rather than buying a scrubber for the sake of that purpose. And it is on an outdoor cooking purpose. Hopefully, it will not really cause much harm to the equipment.
No, it's not a harm that I'm concerned about. It's the government approval for this to be done for consumer-grade.
Yeah. Okay, so it is on a test bed basis, so therefore it is okay. But there's no restriction on methane use, biogas use. So to answer the question, we have no policy per se. Thank you.
Is there another question? If not, I have a question for you. So I was just wondering, how resilient is it, the design to the climate events, like whether if there is any disasters like typhoon or something like that?
Yeah. Okay. That's a good question. As you know, that Malaysia is outside of the lingkaran api Pacific, right? So we talk about earthquake and typhoon. We are being blocked from both ends. So this particular design, it is not designed for that purpose. However, it is designed for zero energy and low carbon. Yeah. Prior to this, I came up with another idea, that is to use shipping containers, right? Because shipping containers in IBS is able to withstand a certain amount of vibration and also whatever kind of forces, right? So that was for a different project. To answer that question, it was not for that purpose. Perhaps in the future we can look into that. Okay, thank you.
Thank you very much. Okay, thank you, Dr. Alvin Long, for the presentation. Please give a round of applause for the presenter. Let's move forward to the next session. So the presentation is titled An Energy Efficient Multi-Array Sensor System Integrated with AI for Classification of Rice Grade. That will be delivered by Mr. Muhammad Shakir Muzamir. So Mr. Muhammad Shakir Muzamir, the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum and very good morning. Thank you, Mr. Chairman, and all the members from the floor. Okay, my name is Muhammad Shakir bin Muzamir, and I'm from University Technical Malaysia Melaka, UTEM. Today I would like to present our research and innovations for the energy efficiency that we use the multi-array sensor technology system integrated with the AI for classify the rice grade. Actually, this research and innovation it's not very contribute for the energy efficient so much, but I believe this technology will give big contribution to the community, especially for the rice eater. Okay, like ASEAN, we all eat the rice, right? Move forward. Oh, okay, sorry. Okay, and this is our team, me, Muhammad Shakir, and our mentor, Professor Burhanuddin, and also our student, Izwan Abdul Razak. So for the background and motivation for the research, this research innovation, that rice is a staple food, okay, for the more than half of the world's population, and the ASEAN nations, Thailand, Vietnam, Malaysia, and the Indonesian country are the top producers and exporters of the rice. And the rice grading is the key market value for the consumer trust and export quality. And also the manual grading using the human is slow, subjective, and inconsistent. And if you can see the graph here, this is the rice yield across the ASEAN member, that from the 1961 until 2019, okay, the rice, the production of rice is increased by years. Let's go to the problem statement. So the problem statement for this research innovation is using the conventional image and base of grading system often require high computational power and substantial electrical for imaging processing and sorting. And using the human inspection is very subjective, slow, and also inconsistent, especially for the underlying throughput, the field conditions. But for the small producers or the community that mills often cannot afford this upfront cost of the technology of AI vision system and the power supply of infrastructures. So right now we have already the rice sorting machine. Okay, this rice sorting machine can create the rice. However, the energy efficiency and also the value, the cost is not cheap. It's expensive. So the previous work, okay, for the rice grading is focusing on the accuracy, but it's not focusing on the energy efficiency and few integrated system, combining with the multi-sensor technology with the AI and the low power architecture, and the most existing research on the rice grading focus on the accuracy on all the vision-based methods with the limited attention of energy efficiency, AI integrated sensors, especially for the ASEAN country. So we come up with the objective to design the energy efficient multi-array sensor for rice grading, detection or classification, to integrate the lightweight of AI algorithm for classification and accuracy improvement, and to evaluate the classification performance and effective of the proposed system. So this is the methodology for the classification. Basically, we have the training phase and also the classification phase. So the raw data from the rice, okay, we come up with the two parameters in the rice grading, which is the odor or smell, and also the color. And the extraction of the color and odor will be trained in the training phase. And then we will going to classify at the classification phase, where the raw data or the real-time data of extraction features by odor and color will be classified using the algorithm classifications, and we will label the real-time data that across our system. So process of classification. So first, we are identify the stability of the sensor, which is using the smell and also the color, and develop the multi-array sensor for the rice classification, where we use, for the smell, we use the MQ series sensor, and for the color is TCS sensor. Then we have training and analyze the data pattern, store the case of library into the database, and we test or we evaluate the system. Okay, this is the architecture. We use the color and smell parameter and microcontroller, also the classification algorithm, where we choose the decision tree algorithm. And this is our prototype model. We have the chamber of the rice samples. We have the LED that mount to our prototype, and the body of the microcontroller that we use 5 volt for the microcontroller to supply the power, and we use the lightweight AI to make sure we can classify the rice grade. So this is the true prototype that we developed for the energy efficiency design by using the 3D printer. So let's go to the experiment setup. We set up the rice sample for the import and the local rice, where in the Malaysia, the rice, the price of rice is difference between the import and local, because the local price have the subsidized from the government. And why we choose the import and local? Because previously we have the issue where the import and the local rice has been mixed, and they sell the rice for the highest price to get more profit. So this is innovation that we use, okay, to classify the percentage of import rice and the local rice. And the way we take a sample of 100 gram, and other sensor for the 4 MQ series sensor, and GCS 3200 as the color sensor. And the time taken for the testing is 60 seconds to classify the rice grading and data library from the raw data we collect from 4,800 raw data. So the evaluations of metric, we have accuracy, precision, recall, F1 score, and specificity. So result and discussion, this is the confusions metric result, where we test 15 times for the local rice and 50 times for the import rice. For the local rice, we predict 9 over 15, means more than half of percentage that we can predict the local rice, but we predict imported for the actual local 6/15. However, for the imported rice, our system predict 15/15 for prediction. From this result, we come out with the performance result, where we discuss here in the performance summary. Sorry, there are typing error there. Okay, so for local rice, precision and specificity, we got 100%, where all the predicted local rice were truly local. And the recall result, we got 16%, 6/15 local samples misclassified as import. F1 score 0.75, trade-off between the perfect precision and low recall. And inside the system, avoid false positive but miss some genuine of local rice, low sensitivity. But for the import rice class, we got 100% for all imported rice correctly identified. Precision at 71.4 percentage for same local rice misclassified as imported. And specificity for 16% for the weaker rejecting of the local samples. And F1 score for 0.833 for the good balance result, but false positive need to reduction. For insight reliable for fraud detection improvement needed for the more precision. And for the conclusion, our system, proper system, innovation and research, now we got accuracy for 80%, effective for use low cost sensors and plus the decision tree AI. But there are limitations where to lower recall for the rice due to the overlap, volatile of compound, sensor drift, and storage effects. But we have potential to strong for the real world deployment, especially for detecting the imported rice. But for the future, we identify that we need to improve the rice recall result and imported rice precision. We are using the features optimization, dataset expansion, and also the hybrid artificial intelligence algorithm. That's all from me.
Thank you very much, Mr. Muzamil. So I would like to give the audience for the Q&A session, if there is any question. Yes.
Okay, good question from industry. The end user for this technology first is focusing on the government's agency. Previously in Malaysia, we have a government agency from Mardi that we use. They have their own lab, but they use the genetic of rice to classify the grading of rice itself. But there is no what we call another parameter such as smell and also the color to that can help the industry to classify it more accurately. So we targeting for the government agency. That's my answer.
Does anyone have another question?
Hello, I have a question. So how do you calculate how efficient your technology? As you mentioned, it's energy efficient just now.
Okay, we claim as energy efficient because our because our technology is used only for 5 volts electric, and also difference to the commercialized technology that already in market that use 240 volt and the expensive in price. So we can we decide, or it's not decide, we claim as the energy efficiency because in terms of low cost and in terms of energy use is very low, but can have 80% accuracy for the grading classifications.
Any other question from the audience? And I think I have a question for you, Mr. When you mention about the energy efficiency and it is being compared with the existing technology in the market, my question is there any measurable metrics like how many percents of energy saving maybe?
Okay, for the percentage of energy saving, we currently not exactly calculate the exact saving of energy or the carbon right now. But for the future, yes, we are going to patent and copyright our product. So we will do future investigation and research to make sure our product and our innovation will meet the requirement of the SDG of energy efficient.
Okay, thank you very much. Please go back to your seat and give a round of applause for Mr. Muzammil for the presentation. Let's move on to the next session, and it will be delivered by Mr. Alwin Long again, with the presentation titled Bridging Energy Audits and Performance, a Policy to Practice Case Study Using EACG and EAEMIS or AMAS in the Private Healthcare Sector. The floor is yours, Mr.
Okay, thank you, Mr. Chairman. Right, the methodology is to use a global framework, a regional alignment, a national policy, and also an ESCO-led, which is a company, local company-led, and working with the institutional localization. Right, we have UNSDG, we also have AMAS, which is for ASEAN. And the national policy that we focus on is the Energy Efficiency Conservation Act, and also using the Energy Audit Conditional Grant. For the ESCO, there's this model which is called the Sustainable Energy Management Program. Right, the institutional is a hospital. Right, globally, the target of SDGs that are being applied here is SDG 7, 8, 11, and 13. While this regional, if you are aware of AMAS, which was back in 2010, right? It is actually a sustainable consumption program from European Union, and then they went into ACE. I think ACE actually applied for this particular grant. That's how it was formed for the thing that we are now enjoying, which is called ASEAN Energy Management Accreditation Scheme. So back in 2010, that's when they have launched this, and Malaysia took it up lock, stock, barrel. We, under MGTC, Malaysian Green Tech Corporation and Climate Change, they actually pushed this to all the hospitals across Malaysia. All 200 over hospitals, government hospitals, are certified either 1-star, 2-star, or 3-star. I would say that 99% are already 3 stars. Okay. To couple it up, we also applied the Energy Audit Conditional Grant that has been in running for 2 years now. Right, I heard just now one of the presenters say how much Singapore as well as Malaysia, we do have policies to facilitate energy efficiency. So this grant has been around for 10 years for RMK 11, Rancangan Malaysia ke-11, and also Rancangan Malaysia ke-12. So these audit grants are being given to commercial buildings as well as industries for them to embark into this energy efficiency journey. So as an ESCO, we are registered under Suruhanjaya Tenaga, which is the Energy Commission for Malaysia, and also the Energy Commission for Sabah. We have participated in the MESCO, which is the Malaysian ESCO Association, and also a member of the CEO Network that focuses on ESG. The services that we provided are under MyHijau, and it is also B Corp certified, if you are aware of such certification. So this is executive summary for the hospitals. They are participants of the Low Carbon City framework. There's achieved 3.4 megawatt hour savings and 2,689 tons of CO2. Right, the savings is actually reaching to 30.8% on their 2019 baseline. Okay, again, this is what we do. But what I like to focus in is actually these 2 parts, which are the pillar. That we managed to guide and work with our customer to achieve this goal. Energy audit and also sustainable energy management program. So we performed the audit back in 2017, which is RMK 11. The savings, the energy saving measures was presented here. It can bring about 18.4%. But later part, when we actually worked on the Sustainable Energy Management Program back in 2019. That is when we realized initially the plant was running at 1.3 kilowatt per ton, which is equivalent to using 632,000 ringgit on the cost of operation. But when we went in 2020, we realized it is currently extra cost, right, which is about 824,000. Okay, so and what happened in 2021? It has even further deteriorated. Now it costs almost 1 million to operate that. So there's an increase of more than 40% of energy consumption because of its deterioration. So our recommendation to them is to look into energy performance contracting, which zero capex, you do not need to spend any money, and you can bring it down to 0.68 kilowatt per ton, and an operating cost of energy cost about 320,000. So that would be 700,000 over 1,000 ringgit savings per annum. Okay, so this is an EPC process. One of the reasons why it is unique because we actually ran this on a tender basis. Most of the energy performance contracting across the world, it is on a direct deal basis. So we actually ran CPMV, which is Certified Professional Measure Verification Baseline. We gotten a third party to measure the baseline so that all the participants of the contract is able to look at the same data. PDA is project development on this EPC proposal. We did the EPC implementation. We verify and measure the savings with the same sets of tools. Okay, so that is how it's being done. So we carried out, unfortunately, it was in the spat of COVID-19, and that was why it was delayed. Right, so it was a kickoff session in the middle of COVID-19. Okay, so everyone agree. So we gotten the EPC contractor 1, 2, and 3 to come and to see which are the areas that they like to measure and what are the items that they like to see in order for them to come up with a proposal, because it is an energy performance contracting. Any one of you are not familiar with EPC? Okay, EPC is a contract that the supplier or the vendor will invest on your behalf. You don't have to pay a single cent on CAPEX, but it's through your OPEX that you actually fund your energy saving measures, right? Okay, so for the CPMV, that's when we install the equipment which are agreeable to 3 of the contractors. So they agree, okay, this is where we install our flow meter, this is where we install our temperature loggers. And then from the data, we will upload them in the cloud that they can draw and come up with a proposal. Right, and this is the actual implementation. The efficiency is 0.67 kilowatt per ton, 0.01 kilowatt per ton more efficient than what we expected. Okay, we have gotten magnetic chiller, which just now Prof. Fani was talking about. They chose VSD chiller instead of magnetic chiller is because of cost. But if they were to have chosen this methodology of energy performance contracting, then there's no cost incurred, right? Okay, that is the portion on energy efficiency. On the energy conservation, that's when AMAS comes in, ASEAN Energy Management Accreditation Scheme. We established the Sustainability Committee and also the Energy Committee. From Sustainability Committee, which is the overarching portfolio of sustainability, then we have the Energy Management Committee that comprise of management level people up the way to the head of department, then the Energy Working Committee, which are the working level people. So I work with all 3 across so that we are able to send the same message to deliver this. Energy management matrix is one of the methodology that we measure before and after on 1, 2, 3, 4, 5, 6 different important pillars that we can implement with 3 different layers on fundamental, intermediate, and advanced, right? So you can see the blue color is where they were when they first started off, and green color is where they are at this point in time. In order for us to encourage energy conservation, a lot of turun padang, we call it in Malaysia, or we call it as engagement, community engagement with the users. We have town halls, awareness training, and frequent EMC and also EWC meetings. All right? We also invited speakers from outside to give awareness in order for them to get excited about this program. right? This is the recent energy awareness program that we did. We printed out exactly what we have done, how much savings we have, and we went down to the people and we educate them the things that we have. Okay, so here is the energy savings with 2019 as a baseline. As you can see, the kilowatt hour that is being consumed, while the carbon emission and also the building energy intensity, it is actually in a reduction trend. And currently, a total of 3.4 megawatt hour savings, which is equivalent to 31%. Right? So you can see this particular chart, the baseline year, what are the activities being carried out and where they are at this point in time. Okay, and this is a reflection of CO2 and a direct comparison between 2019 and 2024. So there's a 30.8% savings. And most recently, which was just last month, we actually won the National Energy Award. And we aspired to win the ASEAN Energy Award for the same activity for large building installed base in Malaysia. I think that's the end of my presentation. Thank you.
Thank you, Dr. Alvin Long. If there is any question from the participants, from the audience, please raise your hand. Yes, please.
Yeah, thank you. Yes, I enjoy your presentations. So I'm curious about the energy performance contracting that you have. Is it a shared savings or guaranteed savings contract with the energy service company, and how long the contracts with the energy service company?
Okay, thank you. So EPC, there are different models. This particular model is on shared saving basis, right? There are three contractors, and each contractor can come up with two potentials. Some are 20/80, 30/70. The bigger the savings, the shorter the duration. So the one that we chose was actually the longer the duration, but the smaller, bigger savings opportunity. Why so? Is because this particular contractor bundled their maintenance cost on the energy performance contracting. So in other words, if let's say we've chosen 8 years out of 10, the last 2 years we need to pay our maintenance. Right now this one is, we chose 10. All 10 years is maintenance free. All right?
Is there any other follow-up questions or another question? If not, so thank you very much for your presentation. Let's give a round of applause for Dr. Alvin Long. So the next presentation is about analysis of power harvest in simulated model of floating solar PV system against stationary installation. That will be delivered by Engineer Lovely Mai Daksa. So the floor is yours, Miss.
My respect to the panelists, to the chairman, and to everyone who's here with us today. Good morning. I am Lovely May from Caraga State University from the Philippines. And allow me to share this collaborative study with our undergraduate students in the university under the BS Electronics Engineering program entitled The Comparative Analysis of Power Harvest in Simulated Floating Solar PV System Against Stationary Installation. We have here the students, Jeric Junzon, Vincent Limicompal, the faculty members, Charlie Main, Celio Renete Mendoza, and yours truly. So the increasing demand of renewable energy source has led significant progress or advancement in PV technology, particularly in the context of floating PV systems. So as shown in the presentation, the Philippines had exhibited a strong upward trajectory in photovoltaic adoption, increasing from only 2 megawatts in 2011 and now approximately 1.63 gigawatts in 2022. So this growth significantly signifies the country's expanding reliance on renewable energy systems that is part of the national energy diversification strategy. So, however, one of the critical limitations of large-scale solar expansion in the Philippines is land availability because ground-mounted solar farms require significant land area, often competing with the agricultural and residential land use. So, to address this challenge, floating solar photovoltaic systems have been introduced as a space-efficient and thermally optimized alternative. So in our university, we are conducting several researches under the solar photovoltaic system. So on the right portion of the slide also, a floating PV setup or what we call the dynamic, and a ground mounted or what we call the static. So the dynamic configuration introduces mechanical movement due to the wave action, altering the panel tilt orientation and potential exposure to sunlight. So to quantify these effects, this study compares the power output of a simulated PV system and stationary system under identical weather conditions, and both setups were tested at tilt angles of 5, 10, 15, 20, and 25 degrees using a theoretical modeling supported by prototype experimentation. So the objective is to determine how tilt angle variation and hydrodynamic motion influence the energy harvesting efficiency of floating PV systems and to identify the optimal tilt configuration for maximizing the solar power generation under tropical conditions. So ultimately, the study contributes to the growing body of knowledge in the solar PV performance optimization and providing empirical and simulated insights in the potential large-scale deployment of floating solar technology in the Philippines, particularly in the Mindanao region, in our area. So several researchers have explored the performance of floating because floating is not really new already. So for instance, one of the study investigated how varying tilt angles affect floating PV performance, and there are another study conducted in comparison between floating and land-based PV system and observed a 5 to 10% improvement in the efficiency. But from these studies, we can observe that most of the existing works focus on cooling effects, stability, and general efficiency improvement. However, very few studies directly compare the actual power harvest between a simulated dynamic floating PV and a stationary ground-mounted setup under the same conditions. This identified gaps forms the foundation of our study. Unlike most existing works that separately study floating or stationary systems, or study perform a comparative analysis between the two specific evaluating power harvest performance under identical simulated environment conditions. So our approach combines simulation and experimental prototype testing, allowing us to validate theoretical predictions with actual measured data. So however, we incorporate wave-induced motion and tilt variation factors that have not been extensively examined in previous studies but are crucial for realistic floating PV system behavior. So this is just a continuation of our previous study in the university. So through this integration, our study provides data-driven insight on how dynamic movement affects overall energy efficiency. So finally, the study also contributes to the sustainable energy development, particularly in our country in the Philippines, by proposing a system that optimizes energy production without requiring additional land area, addressing both energy and land use challenges. So here in this section presents the system design and implementation. So allow me to share the black diagram now. In the figure illustrates the static solar PV monitoring system, which records the power harvest of a solar panel setup. In contrast to the black diagram in this other side, the dynamic solar PV monitoring system, which incorporates a motor driver to control the two actuators, allowing the setup to create a wave-like movement. So the static and dynamic solar PV monitoring system are designed to monitor the power harvest from a solar panel setup. Both system uses an MPPT module to optimize solar energy output, stores energy in a battery, and step down the voltage using a DC buck converter. So a voltage regulator ensures a stable supply to the microcontroller. Current and voltage from the solar panel are measured using the AICEE S712 sensor and a voltage divider respectively. So, and the sensor and voltage converted to digital signals via ADS 1015. The RTC provides real-time timestamp, and all data is stored on the SD card only for this study for the analysis. The dynamic solar PV monitoring system enhances dynamic setup by incorporating a second Arduino Uno and L298 motor driver to control two actuators. So these actuators enable the simulation of a wave-like movement in the panel. So we have used 430 watts PV solar panel and a 12 volts 100 ampere hour gel battery type. So the team used SD card for the data logging and collected the data at the end of the testing each phase. So this is the tilting mechanism of our dynamic solar monitoring system. So this illustrates the tilting mechanism, and it consists of a primary axis for east and west rotation and the secondary axis for the north and the south tilting. Actuator 1 control the east-west movement, while actuator 2 adjust the north-south tilt. The side and the back views show how these actuators work together to produce wave-like movements on the dynamic solar monitoring system. The actuator controller device, the motor driver, and Arduino Nano generates controlled motions for the solar, simulating realistic wave-induced movement. So for this study, the wave motion pattern was derived from the average pitch and roll measurements previously recorded at the Lake Mainit in Agusan del Norte in Mindanao, because this is one of the largest lake in the Philippines, because we have implemented our study there also, our floating. These recorded parameters represent the typical wave dynamic observed at the environment, including the amplitude, frequency, and the angular displacement of surface motion. So by using these real-world values as reference data, the present research was able to replicate a wave-induced movement through the actuator-controlled dynamic tilting mechanism. So this ensured that the simulated wave motion closely mimicked the actual environment conditions. Furthermore, this study is designed as a continuation to the previous research, extending its scope from environment wave to characterization to practical application already. So specifically evaluating how such wave-induced dynamics affect solar panel performance and power generation efficiency in floating PV systems. So we have here the testing methodology. So the experiment was conducted across 5 testing phases because we have very short time, a period of time, so we have conducted for 30 days. So for the static setup, the tilt angle remained fixed, and while the dynamic setup continuously changed its orientation by simulate wave-induced motion deviating by 12 to -9 degrees. And for the roll, and for the pitch is positive to -6 degrees relative to the present angles. Now, these deviation parameters were based on the actual wave motion data gathered from the Lake Mainit. So the frequency of data collection was every 30 seconds using a solar panel monitoring system equipped with data logging capability. So for data analysis, so we have used 3 statistical measures: the mean, the maximum, and the minimum values of the recorded power outputs. The mean represented the average performance across all readings, while the maximum and minimum identification range of variability in energy harvest. So in summary, this methodology ensured that both simulation and prototype testing were conducted under identical environmental conditions. So we have here also, this is the setup, and furthermore, we have used the linear regression analysis to establish calibration equation for the sensors, ensuring the reliability and accuracy of the recorded data. So the deployment site for this experiment was located at the roof of our building and engineering at Caraga State University in the Philippines, providing an open roof environment ideal for an unobstructed solar exposure and control system set up. So sensor calibration was performed to improve reading accuracy. Sensor outputs were compared against a calibrated digital multimeter, and the data were collected to determine the average error of each sensor, which were corrected using an equation derived from the collected data. So we have here the results for our 5 phase with each 6 days. Each phase signifies different tilt angle settings for both setups. Roll, pitch, and angles for dynamic setup were also changed per phase. So in this section, the results from the entire duration of the gathered data are discussed. The power output of each system is compared, including their graphical analysis and the power harvest. So I will just give you the summary of this because it's very long. So it summarized that the static setup consistently delivered higher power output compared to the dynamic setup for the entire 5-phase, 6 days each phase. Okay. So in our research paper, the discussion of each phase is already presented there. So we have here the overall, the power of the boat throughout the phase 1 illustrates that the static is more consistent, and then we have here the matrix for the power harvest per phase. So the matrix provides a detailed breakdown of power output per phase for each system. Overall, the static setup is 6.08% more efficient than dynamic setup. The static setup yields a total harvest of 33.2 kilowatt hour throughout the phases 1 to 5, while the dynamic setup yields only 31.18 kilowatt hour just only for 1 month. Overall results show that 6.08 efficiency advantage, with the static consistently outperforming the dynamic one. So the dynamic systems output fluctuated due to the wave motion and weather instability when you put it in the lake. While floating PV allow tilt flexibility, the study concludes that the static systems provide more stable and more reliable energy production, especially in environments with frequent motion or variation in weather conditions. So here we have the general research conclusion. So the study effectively monitored voltage, current, and power using sensor for each parameter. Additionally, the dynamic system successfully simulated the average, maximum, and minimum pitch and roll movements recorded from Mainit Lake. So the analysis carried out for the 5, 10, 15, 20, and 25 degrees still provides useful comparative insights into evaluating the performance of the static and dynamic solar panel systems. During the entire period, the static model consistently demonstrated higher power output with peak readings exceeding those dynamic models. So the study found out that the efficiency and output power drop when the tilt angle deviates from optimal positioning when there is a wave motion, so indicating the need for the dynamic or adaptive alignment in the future study. So for the recommendations, so for future works, so we would like to propose enhance the dynamic system by integrating a real-time solar tracking, which is very rampant nowadays, or adaptive angle control for improved alignment accuracy, conduct field tests under varied weather and seasonal conditions, add IoT monitoring for remote data collection analysis. We are conducting this using SD card, and use low power actuators to improve the system efficiently, and then evaluate the cost effectiveness for large-scale application. This is very much important in our university because we are granted with several clean energy research project, and we are conducting solar floating system in Mindanao. So this project is our motivation to have an alignment on the solar floating system in our university. I think that's all. Thank you for your attention.
Thank you very much for delivering the presentation timely. Unfortunately, because of the time constraints, it's unlikely to have a Q&A session. So
I like
let's.
that.
Apologies for that. So let's move on. Thank you very much, and give a round of applause for Ms. Daksa. Okay. Let's move on to the next session, the last one, a presentation on. What's that? Okay. So let's move on to the last session, a presentation on the multi-objective optimization of a hybrid energy storage system for community loads using deep reinforcement learning, which will be co-delivered by Liu Puzang and Nur Azwan bin Muhammad Kamari. And the stage is yours.
Good morning, everyone. Dear distinguished guests, colleagues, and organizers of the 5th Asian International Conference on Energy and Environment. My name is Liu Puzhuo, on Faculty of Engineering and Built Environment, the National University of Malaysia. Today, I'm so excited to represent my research on optimizing a hybrid energy storage system for community load uses deep reinforcement learning. This work addresses critical challenges in sustainable energy integration and to enhance economic, environmental, and social outcome. So, my presentation is structured into 4 sections: research background, research method, and research result, also research significance. Now I want to introduce the current status of Asian energy. The Asian Power Grid, or APG, has been a cornerstone of the Asian Plan of Action for Energy Cooperation. The APG aims to integrate energy system across the member states through cross-border. As shown in Figure 1, the grid energy exchange also enhances regional energy security. So also the Figure 2 highlights the electrification rates across Asian member states, showing the significant progress, but also need innovative energy solution. Research background about the status and the vision of renewable energy in Asia. The Figure 3 showing the electricity generation from 2005 and 2022. And the Figure 4 projects electricity generation for 2050, showing a rising demand by the economy and population growth. Renewable sources like the solar and the wind are expected to expand significantly due to the technological advancement and the cost reduction. The rise of artificial intelligence, particularly deep learning and reinforcement learning, has transformed energy system analysis and control. The Figure 5 shows the smart power system structure. Research background about now also have some research problem of the hybrid energy storage system. I think they also have 4 problems about. The first is integration, and the second is optimization. The third is adaptability, and the last one is sustainability. Now, I will introduce my research method. So, the first, this is the system configuration. The system consists the following main part with power flow managed through a DC bus for efficient energy transfer. As you can see, they also have a wind farmer, PV farmer also have the storage such as the battery and the thermal energy storage or TES. Also, the Figure 7, this is show a daily typical community load model. This is a way to solve the problem to satisfy the community load demand. So the system aims to meet real-time load demand. Also, this is keeps the balance. Also, they also have a coordinated operation structure. So such as the charging model. When renewable energy generation exceeds the load demand, maybe the energy is prioritized for storage in the battery and the TES with the following strangers. So the battery charge will be the first, as due to its faster response and the high efficiency, make it suitable for transmitter surplus power. So the second is the TES charge. He will buy electric heater. So when the battery full charge or supplies a net load, so energy will converted to the thermal energy for storage in TES. So TES charge is suitable for store the large amount of energy, supporting maybe middle or long-term energy management. So they also have another problem, also is discharging model. So when renewable energy generation is not enough to meet load demand, the battery and the TES discharge need to cover the power. So we use reinforcement learning to dynamically discharge logic, optimizing battery and the TES behavior based on the following rulers. The first is the battery. Battery will be the first for discharge because it's so fast. The battery first to discharge is fast response and the high efficiency make it ideal for handle the transit problem, also have the low power load. And then, if the battery discharge can't satisfy the load demand, so the TES also use power bank. TES is suited for a high power such discharge, effectively meeting the high load demand. Also, they also have coordinated discharge, and both the battery and the TES also have available capacity, so they can together discharge to satisfy the community load. So the research method. So this is our optimization objective. The coordinator optimization aim to measure the NPC and the LPSP to balance the economic efficiency and reliability. NPC also called the net present cost. They also have the initial investment, also they have the operation and the maintenance. So also have the replace cost, also have a discount to present value. So this maybe this part about the economy. So the next objective is about the loss of power supply probability. LPSP, he will measure the system reliability. It's very important. So LPSP reflecting the system's ability to meet demands. So the decision available for coordinator optimization, including those factors. Now I want to share my research result. So we can see the figure. The NPC and the LPSP. We can keep the balance and find the red one. Maybe if we want to system more reliability, you should spend more money. I think no one wants to spend more money to satisfy the LPSP. So you can keep a balance to find a point one. And right is about the solution. So about the wind installed power, also solar installed power of battery power, also battery capacity, also TES capacity. And we can know our method, maybe the TS capacity is more high because it's more cheaper than battery. So our method will focus on the economy problem, but we also focus on reliability problem. So the next one is my research significance. Also have, I think also have a 4 point about the academic, also have the economy, also have the environment, and also have the society. So thank you for your attention.
Thank you very much. So we still have around 4 minutes for the Q&A session. I would like to give the floor to the audience for the Q&A session. Any question? Yes.
Thank you for your presentation. Is there a difference if it is an off-grid system or if it's a non-grid system? Looking at it, could that be used for grid which are not stable, not like peninsula, somewhere in
Oh. Sorry. Can you?
I see that your research is on an off-grid system, correct?
Yeah.
How can this be applied on an on-grid system? Is there a possibility?
I think my research is more ideal, such as I just want to the zero emission, such as just rely the wind and power. So this is off-grid. But I think maybe such as for some remote area, maybe the grid can't satisfy. So we can build the wind and the solar and to satisfy the community demand about this. But I think maybe I also think maybe also I can add on the grid, also the grid net, but this will be more complex and also can't achieve in some remote area. So, okay, thank you.
Basically, it is a DC system. That is why it's more on the off-grid.
Yeah,
Right?
yeah.
So it is not an AC.
I think I also is off-grid, yeah. Okay, thank you.
So is there any other question from the audience? If not, you may end your session and you may return to your seat again.
Okay.
Thank you very much and give a round of applause for Mr. Liu, please. So thank you very much for all presenters for sharing their insightful research and experiences, and to all participants for your active attention and engagement throughout this session. So our discussion today has highlighted that the importance of energy efficiency technologies and measures in advancing ASEAN's sustainable energy transition. So the ideas and perspectives shared today provide valuable input for enhancing regional cooperation throughout the ASEAN and accelerating practical actions toward a more efficient and low-carbon future. So I hope these exchanges will continue to inspire collaboration and innovation among all stakeholders working toward ASEAN's clean energy goals. So with that, we officially conclude this morning session of the 5th ASEAN International Conference on Energy and Environment, or AICEE. However, we still have some other sessions, such as we have a poster exhibition in front of this room. Also, we have coffee break in the hallway. Please enjoy yourself while in this area. So thank you very much, and Afam, see you next time.
like I'm God. I'm ready to go on this one. Yes. 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 How will I choose? Okay, it will be given when I'm presenting. Oh, okay, so I will be given right. Okay. Thank you very much.
Good morning, everyone. I was a bit hesitant to start without an audience, but Mr. Sahonia, right? Sahonia, he will be presenting two papers, so we will have time for Q&A. The others will catch up. Okay. So good morning again. I'm Dr. Aries Queen Macabebe. I'm the session chair. Today we have 6 presentations for this session, the second session on low carbon and emerging technologies, but we have 5 speakers. So we'll start first with the first presentation of Mr. Edgardo Ricardo Sahonia Jr. The title is Optimized Integration and Performance Evaluation of IoT-based Smart Solar Street Lighting Systems utilizing multimode communication technologies for sustainable infrastructure in the Caraga region, Philippines. So let's give him a round of applause.
Hello, good morning. Thank you, Ms. Chair, and fellow researcher. I'm here to present our research, optimize integration and performance evaluation of IoT-based smart solar street lighting system utilizing a multi-mode communication technologies. By the way, I'm Edgardo Ricardo Visahonia Jr. from the Center for Renewable Energy Automation and Fabrication Technology, or CRAFT, in Caraga State University, Philippines. For our motivation, we are in a Caraga region. We usually face this problem. A Caraga region in Philippines is near in the Pacific Ocean. A typhoon usually visit Caraga region several times a month. No? So playing from 2 times a month, twice a month, or thrice a month. So this region usually exposed to the typhoon every month. And due to that problem, when typhoon strike or hits the Caraga region, we usually suffer this blackout. No current for after 3 weeks, 1 week. Sometimes, just like happened when Typhoon Rai hits Philippines, Caraga region experienced almost 1 month before the power restore. So in those days, we usually experience those dark nights because no lights at all. Then with that problem, we are we come into our mind to solve it by having a street light using a solar power. But installing a solar power or a solar powered street light in a Caraga region is very challenging because Caraga region itself is a GD areas or geographically isolated and disadvantaged areas. Some parts of the Caraga regions don't have this communication, for example, GSM signal. You cannot find GSM signal, least fortunate region in Philippines. So by solving it, maybe we can monitor the street light, a solar power street light, that we can monitor in any communications technology that can address even there's no GSM, we can apply LoRa, and so that we in our side, we will not go every time visit the mountainous area just to see if our street light is still working or not. No? Especially monitoring the batteries, the solar PV harvest, and everything. And then with that, we include also integrate the proactive detections and detection algorithm so that we can have this proactive maintenance in our street light. So Caraga region, by the way, is composed of five provinces. They are the Surigao del Norte, Dinagat Island, Agusan del Norte, Surigao del Sur, and Agusan del Sur. Vision or Sorbi in the Philippines, the Caraga region is the least fortunate when it comes to the level of urbanization. We have the smallest number so far in all the region in the Philippines. Now, as you've seen in this picture, these people are living without electric line or power lines from the government or from the supplier. But still, they choose to live in those area because they have this way of living here. Maybe they are farmers, yeah? Even though they will sleep early because they don't have this electricity. Just like this one. This one is one of the island in Caraga region. They don't have power lines. They usually use only solar if given a time. But once the typhoon will hit again, all of those houses will be clean. No more lights and no more electricity. So that's the problem. That's a problem of our research. Then our objective is to integrate a multi-mode IoT communication, where if there's no GSM signal, we still monitor the street light if it's still working, especially into the island, and then make it is scalable, that will be a relative system that can be installed in all area of the GD areas in Caraga. Then we develop also a Laravel-based monitoring dashboard where we can detect automatically if there is a problem of the street lights we installed in the different areas, and then evaluate the system performance. So this is our system framework. First, we have the common street light, smart 20 watts solar powered street light off grid, and then we develop the IoT box. In this IoT box, it can send data via GSM signal if GSM signal is available. If not, then we go to LoRa. We will send the data until such time or until such point that there is what we call the GSM signal available. Or we can implement also WS in. It will cater also WS in for the start implementation of solar light. And then whatever the data will be sent to the cloud and will be stored into the database. And we have this Laravel framework where the map of the Caraga was shown. And then all icons are green. It means that once we see green, there's no problem on the streetlights installed. But if we see red, it means there is a streetlight that having a problem. Maybe the light is not working already or the battery is already dead. It means the fault detection is there. So this is how the wiring diagram of our device or the IoT box. We utilize LilyGo, and then we put the isolation circuit here in the bottom part, and then the current sensor and the voltage sensor on the top part to monitor the battery, the lamp usage, as well as the solar panel harvest. We add the features if ever the battery is full around 11 EM or 70% full. The community or the people from the community can charge their mobile phone just in case it's still a sunny day. Okay, so this is our the first part is our PCB design, and then we integrated it with any solar charger. So in this figure, we use this common solar charger available in Philippines, but we can use any other solar charger controller. So the one in acrylic is our IoT box. So this is our protocols, the communication we use now. Using a GSM via TCOL, we gather the solar panel harvest, the solar charges, the battery status, DC levels, as well as the lamp. Using those sensors, gather those data, and then send to SPTTGO. Once there is a GSM signal, then it can automatically send to the web server, to the database and dashboard. But if there's no GSM signal, we will use LoRa. We will send the data from one station, from one street light to the next one until such a way that there is a GSM signal on the last one. That the last one considered as the gateway. So we have the maximum LoRa of a maximum range of 15 kilometers interval from one street light to the next street light. But if there is what we call the star implementation of the street light along the crowded city, the crowded community, we have we also implement this protocol that all of the street lights surrounding the gateway, and the gateway will send all the data of those street lights to the cloud. So this is our dashboard that we developed. The mobile app was developed by MIT App Inventor, and then the dashboard for the web is by Laravel. With obviously we have the database. And then you can view the status in each street light. We can zoom in if you have 20 in that certain place, then you can zoom out, zoom in, and then such time you have those 20 street lights, and you have those data. What unique in our research is that if there is one street light not working in that place or in that community, you can see that a plug become red. Then when you are going to zoom it in, you will notice that out of those 20, there is one or more that is red. It means there is a problem. And then once we go in deep on that certain street light, we will notice the data of that street light, and then we can interpret which one is the problem, the battery, the solar panel. Yeah. So this is our error coding, and later in my next paper, we include AI to determine this time series of data. So based on this time series data, we assigned error coding so that the user of that dashboard can know that will be the problem of that street light. Now, not just implementing that there is a red, it means there is a problem. You should always also know that in that street light, this is the problem. Then when you go to that site, you need to bring those components that is not working so that it can fix. It means the maintenance part of the street light is being eased for this technology. We also compare the LoRa and WAs in captured. If what will happen, we know that the LoRa is a long range, and then WAs in is short range. But based on the data, based on our result, we usually have the high accuracy if we use WSN. So if given a chance to implement this in a certain community, our first choice is to use WSN. But if we have no chance, then we get into the LoRa base, because if the politics or the leader, community leader wants I want that this one is in this point, then the next street light is in that point. Now we have no choice because that's their one. So we need to address their wants. So if it's very separated by a very long distance, then we implement LoRa. But if it's this separated by a short distance only, we can implement WSN. So these are the performance evaluation between the LoRa and the WSN. And then this is a sample of the results. And based on this time series data, we develop an AI framework to detect the fault of this data. So in a conclusion, we addresses the GIDA infrastructure gaps via IoT integration, support Caraga clean energy and smart city goals, since Caraga is gearing up to the smart city. Then the AI-based fault prediction that we develop, and then for future, if we can integrate GIS also for this technology. Our key findings: it enhances energy efficiency and reliability, proactive maintenance, and improve monitoring, adaptive control features, and increase operational resilience. Thank you for listening.
Thank you for that presentation, Mr. Sahonia. Can we reserve our questions after the second presentation? Because he will be presenting a case, a special case for the Bacuag, Surigao del Norte, Philippines. So you may continue your presentation.
Okay, so allow me to present my second paper. It's an adoption and impact of the EIoT integrated smart solar street lighting and rural electrification, the case study of Bacuag, Surigao del Norte, Philippines. So 4 years ago, I think 4 to 5 years or 3 to 4 years ago, we have already the first version of this smart street light. It was implemented in a Bacuag, Surigao del Norte. It was controlled by a monitored by a microcontroller, and then estimated by using the Kalman filter algorithm. So we filtered the noise using that Kalman filter. I think you can see that one in IEEE publications. So we revisit what will happen, what happened. So our implementation. Obviously, this research has the same problem with the previous one. The rural areas is facing this darkness. Na? So, but this time, it was already installed and was pilot tested in that community. So that's the research problem, the same. And then our objective is just to evaluate what happened in that area, if the system is still working, still okay. And we have the third-party university who conduct the impact assessment for that community with regards to that research output or extension. So basically, this is the seat that we installed in Bacuag, Surigao del Norte, one of the barangay in Caraga region. So that time, we don't have this LoRa, we don't have WCNR like that. We only depend on the GSM signal. In every point of that Bacuag, Surigao del Norte, we only targeted all those area that has GSM signal, because not all area in the Philippines has this GSM signal. So we are using a narrowband IoT in that time. And the drawback of this research is because since some of the area don't have this GSM signal, we cannot install this IoT box on those places. So that's why we come up to the new study, the multi-mode communication, the first paper. We added LoRa. No. So here is the real-time monitoring regions, the same. Then for the implementation of our street light in this part 3 years ago, we staggered the street light, separated it 10 meters opposite side. If you are going to measure the same side, you have a distance of 20 meters. And then if there is a curve of the street, so we align that a driver cannot be I mean, our lights cannot disturb the eyes of the driver of the vehicle, because if they are going to cross, if you put the lights on the front, it will distract their eyes. So we make sure that there is an angle, depends on the curve of the road. So this is the diagram how we installed. The height for the minor roads is 8 meters, separated by 10 meters. Then we implement it using the European standard, the EN 2126 by 126. That how we compute what is the height of our street light needed to use. No? So based on that standard, we have this plan how we are going to integrate, and we refer to the street light. I mean the street that the community also build now. So it depends on the community. I mean the street that they build, and then we cater what's the best street light based in the parameters, the height, the lumens, and the angle. That's why. So basically, our system architecture on that time is only this one controller with GSM. Then the GSM will send the data to the cloud, log to the dashboard, and then detect the line na if there is an error. So at that time, we only installed 20 street lights in one municipality of Philippines, the Bacuag, Surigao del Norte. And then we gathered data for, I think, 3 months at that time. Then later on, the third-party university, they make a survey for that 120 respondents in Bacuag, Surigao del Norte to check if what's the impact of that research deployed in their community. So based on the technical performance of that research is we gathered this average operation time, 11 point hour, and then greater than 60 of the battery. But we don't have this 100% of this. It means in 3 months, we experience some down in the dashboard. No, we cannot get the complete details for the whole. I mean, 100% of for the 3 months. So maybe one of the two or two of the street lights has problem on those few days for the whole duration. Now the EI based time series fault detection we use has the reached this accuracy of 96.2. So sometimes it was detected that it's still working, but in the site, it's already not working. So there is a discrepancy of the model. So that's around 3 point something, 3.8. For the adoption and brightness of the Bacuag itself, no, they reduce this energy usage. So previously they are using coal power energy from a coal plant base, and then based on the bill, electric bill they have. So since they are added 20 solar street lights, so they can now reduce the energy that they use from the Surigao Power Incorporation or Sarnico. So that's the reduce of the bill. Now, this is the certificate of utilization that we received from the mayor of Bacuag, Surigao del Norte, that they utilize our technology using a 10 standalone and 2 cluster. Then here is the impact assessment result conducted by the Agusan del Sur State College of Agriculture and Technology with regards to the Smart Street Link project in Bacuag, Surigao del Norte. So for the community feedback as the result of their survey, 87% only has satisfaction with the 20 street 20 street lights, because maybe some people as in Bay because only few points or of the community has installed while their places are still dark. So maybe that's the bias of the result. Then it improved the safety, mobility, and visibility. Then we suffered intermittent connection if it is heavy rain. Some street light cannot send the data of the system to the cloud if there is a strong rain. So this is the result of their impact assessment, this summary. So most of the key parameters are very satisfactory. Then when it comes to economic impact, it reduces community electric bill. It helps local businesses because since there is already street light at night, they can have this small, medium businessman. They can sell any street foods or like that. So there's already the community at night is already. I mean the mobility of the community at night is increasing. Then it encourages similar smart energy solution, yes, and then shared information to others below it too. Yes, that's the impact, economic impact. Now let's proceed to the social impact summary. So all of the parameters also are very satisfactory, but here in the summary is Improve safety, yes, but increase community interaction. Main resident, yes. Conflict caused by the project, 4% minimal. No. Now, for the overall summary of the impact assessment, we have this very satisfactory result overall. But the respondent comments has this following. No? They want to know that they can use the mobile app also. They want that they can use the mobile app also to determine if the street light in their community is still working. Then how to train them volunteers to know this minor repairs and troubleshooting pertaining to the street light depends on that web app or that mobile app result. No? So they want a training. Maybe we will address their concern after we know about the survey or the result of the survey. So system technically and socially viable for rural electrification, and then the EI IoT integration, improve performance and maintenance. So for the conclusion and recommendation, EI integration solar lighting supports rural sustainability, but our recommendation is to scale deployment to more Caraga GDAS and strengthen the connectivity. Currently, we have 420 street lights and IoT box to be installed this year. No, to add more communities na ma-partner, So to add more communities for this technology. So for the supplemental slide, I think that's all my presentation. But in my supplemental slides, I have the framework on how the EI detects the erroneous battery, erroneous solar power harvest, erroneous lamp. Now, because if we can detect those defect, then we can have a proactive maintenance of our streetlight infrastructure. Thank you for listening.
Thank you very much, Mr. Sahonia. Are there any questions from the audience? Can we have, can we have a microphone?
Oh,
Okay, thank you so much.
Hi. I'm simple question. I'm Yasufume Ogawa from Greenity Energy, which is a energy sector's consulting company. How frequently that the solar panels fault or error happens?
Yes, it's a very good question, sir. And even me, I cannot determine actually. But in real implementation in a certain community, especially in Caraga, now people are not too rich, and most of the people are below average level. So, you know this. It's an awkward to say that I'm also a Filipino. Some of the Filipino are, we call it pickpocketer. You know, if you say that there is solar, they will steal it. They will steal it. That's why. Oh, there's a problem on the solar panel. The solar panel has no harvest. So bring a solar panel there. But when you came to that point, in that mountain, in that area, the solar panel is not already there because someone installed it. Yeah, yeah, that's the problem, sir. Some of the error that based on the that dashboard, once the solar panel is not working, we already expect that someone installed the solar panel on that site. Yes, sir. We didn't experience it that the solar panel has problem, and then in reality in that site the solar panel is there and it's not working. We didn't experience it so far.
Yes.